Okay, so this video is mostly definitions of some numerical techniques, and once you understand them, then we're going to hit you with some calculus concepts to see if you can make some inferences. Okay, so this should be a pretty light compared to the last two units we just did on integration by parts and U substitution. So this should be a little breather for you. Okay, so what do these definitions mean? So these definitions come from your textbook, and if we say left 3, for example, what it means is we're trying to evaluate the area under the curve, whatever the curve is, from A to B, whatever is given in the problem, and 3 tells you how many times you want to subdivide that interval. So you're splitting it up into 3 pieces. Left means we're going to do left-handed boxes. There you go. And so you want the integral like this. So this red shaded area tells you the left 3 approximation. If it's right, obviously the boxes emanate from the right instead. So let me just set that up. Okay, so if I wanted to do boxes from the right, I would set it up this way. Okay, and I would find the area of this box, the area of that box, the area of that box. Okay, now what we do for trap, there's 2 ways to think of this. It's just really the average of right and left. So if you've already calculated right 3 and left 3, you can just add them together and divide by 2. Okay, but you can also just generate them geometrically as well, and that's a little more intuitive. Okay, so a trapezoid is going to connect these points, so you're just following the curve as well as you can, and then you're going to, of course, find the area under that structure that you just created. And the area of a typical trapezoid, when you're doing these things, you draw yourself a trapezoid, and this is height 1, height 2. Actually, this is the height of your trapezoid, and these are considered the bases. My bad. Okay, so the area of a trapezoid is base 1 plus base 2 over 2 times h. So it's the average of the 2 bases. That's the official way of thinking about it. Okay, so that's the official nomenclature. I know they don't look like bases, they look like height 1 and height 2, but we call them bases because we normally put the parallel sides up and down. Okay, so what I want you to know is what's the difference between trap 3 and mid 3. Okay, obviously you change the number of subdivisions, but the difference is, do you actually sample the function in the middle of the domain, or do you just connect? Both techniques have the same order of accuracy, but let me just zoom in. Let me give you trap 1 and mid 1 for just one function. Okay, so I have a function here that's increasing and concave up. So trap 1 would literally connect you from here to here, and you will find the area under that region, and that would be the trapezoid that approximates that area. But what we do for mid 1 is we say instead, along the x-axis, where's the middle, and then we're going to see what is f at that point. Sorry, it's not really lined up. Okay, then what we're going to do is we're going to use that as the height of our box. Okay, now you can see that trap 1 would have the same area as a box that was drawn like so. Okay, so you can see when you have an increased concave up curve, mid 1 is going to give you a value less than trapezoid, and we can do somewhat of an analysis of which one is off in which direction, right? So obviously the actual integral is going to be less than the trapezoid one, in this instance. And we also know the midpoint one is going to be less than the trapezoid. So is the actual one versus the midpoint, which one is better? That's something you have to figure out. So I'll leave that to you and your groups to discuss. But this is what you want to do. You want to zoom in on one piece. If the question says you have a function that's like concave up and increasing, or concave down and increasing, or whatever, create a function that has those properties and just look at what happens to one of your regions. And again, I like to think of this in terms of a circle, right? So the bottom half of the circle is concave up, and the top half of the circle is concave down. And this guy is increasing, increasing, decreasing, decreasing. So you have your 4 examples of your prototypical curve segments that you can use for figuring out these problems. Okay, what I want to do is just make a quick comment about question 4. The problem you may or may not have with question 4 is that you're going to have to estimate. And so some of your estimations may be slightly different from mine. I tried to be really gentle in the quiz, but if you don't get exactly the same answer as me, don't worry about it. Just come talk to me and we'll work it out together. So that is not meant to make you feel penalized for your accuracy. Do the best you can, but it is meant to be instructive. And again, just sort of the grid lines are not drawn in your worksheet. You have some kind of curve that looks like this, and you have some little marks over here. So again, if you're somebody who either is able to annotate a PDF or print out a document, what you want to do is extend these lines on your own copy of the document, and then you use these lines to help you estimate the areas as accurately as you can. It's very hard to do if you're not drawing grid lines on top of the diagram. So that's a great thing to do in your groups, and even if you don't have a way of annotating a PDF, you can display the document in Zoom, and then you can use the annotate feature to draw on top of it. So at least you have something your whole group can get together and talk about that way. Okay, so I will see you guys in class. Take care.